Here is a rectangle 5 centimeters across by 3 centimeters in height. Now we've already seen how we can work out the perimeter of a shape. Now the perimeter gives us the distance around the outside of the shape. There is another useful quantity that we can work out. We can also work out the amount of space inside the shape, this bit here. Why is that useful? Well, because on a practical sense from life, things like carpets, working out the amount of carpet that you need to know how much floor space your room covers. So this is very much a practical real life thing, similar to perimeter, also a very practical real life thing. So we need a way of working out the amount of space inside this particular shape. Well, what I'm going to do here, we're not normally going to do this, by the way, this is just us leading towards finding out some stuff about it. What I'm going to do here is I'm going to first of all take this rectangle, I'm going to look at the 5 centimeter edge, and I'm going to split the shape up into columns. And I'm going to split it into columns so that each column is 1 centimetre wide, i.e. I'm going to split it into 5 columns, one for each of the centimetres along that 5 centimetre edge. And then I'm going to look at the 3 centimetre edge, and I'm going to split this shape into rows so that each row is 1 centimetre in height. So I'm going to have 3 rows in this shape, one for each of the centimetres along that 3 centimetre edge. So by doing that, what I have done is I have split this shape up into small squares, and each square is 1 centimetre wide and 1 centimetre tall. They are effectively centimetre squares if you think about the old classic squared paper exercise books. I have split this shape up into centimetre sized squares, 1 centimetre wide, 1 centimetre tall. How many squares have I split this shape up into? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, or 3 rows of 5 or 5 columns of 3. I have split it up into 15 squares. (15 centimetre squares). Now it shouldn't be that surprising that there are 15 because we have split it up into 5 columns of 3 or 3 rows of 5. So there should be a connection between the 5 and the 3 and the 15. And in fact the connection is that 5 times 3, 5 lots of 3, or in fact 3 lots of 5 depending on which way around you want to write it, gives us the 15. So timesing those two lengths together gives us the number of centimetre squares inside. Now what we have effectively done is we have found what's called the area. The area of a 2D shape is the amount of space inside it. Area is a 2D concept. So the area is the amount of space inside a 2D shape. Because area is something that we can measure, it needs a unit. It doesn't currently have one. The area of this is 15, but 15 what? Well, we can actually get a unit from this idea of centimetre squares. I'm going to tell you what the unit is, and then I'm going to explain why it's that. There's a couple of different reasons why. I'm going to get rid of the centimetre squares, and I'm instead going to give it the unit centimetres squared. So first thing, there's a bit of a sound alike, centimetre squares, because that's what they are, and we've got centimetres squared for our units. Next bit of justification. There are 2 dimensions that we used. We used an across measure and we used an up-down measure, and we times them together. And in doing that, we had 2 dimensions. 2 dimensions, number 2 up here. And the final bit of justification that we can do. We took a centimetre measure and we took a centimetre measure. We have done centimetres times centimetres. And centimetres times centimetres, well, we have timesed it by itself, and timesing something by itself, we have squared it. Hence, centimetres squared. So to summarise that and pull a couple of extra bits out of it, the area is the amount of space inside a 2D shape. Any 2D shape has an area. Some are easier to calculate than others, and some are calculated in slightly different ways. The units for area. The most common unit is probably going to be centimetres squared, but bear in mind we could be looking at a shape that's measured in metres or millimetres or kilometres. So actually, we can say that the units will be millimetres squared, or centimetres squared, or metres squared, or kilometres squared, or in fact any distance unit squared. But if we're looking at an area, we have got these squared units. If we are looking at squared units, we are dealing with an area. But the common ones, the most common one is probably going to be centimetres squared or maybe metres squared, but we could have the other two, or in fact any distance unit squared as a unit for area. We need to be able to find the area of a rectangle, the area of a parallelogram, the area of a triangle, the area of a trapezium, and the area of weird shapes made up of combinations of those. They are not all found in exactly the same way, but we are going to start with the rectangle because we've kind of already seen how we do that. To work out the area of a rectangle, well, we've just seen how we do that. To work out the area of a rectangle, we simply have to take the across measurement and the up-down measurement, that's the two different dimensions, and we times them together. So the across measurement here is 5, the up-down measurement here is 2, we times them together and that gives us 10. We need to give it a unit because an area is a measure of the amount of space inside this shape. We're working in centimetres, so that means our area is going to be that distance unit squared. So it will be centimetres squared for this one, and the area is 10 centimetres squared. Work out the area in metres squared. Now the rectangle this time, so again with the rectangle, all we have to do to work out the area is we take the across measure and we take the up-down measure and we times them together. This works for the rectangle, different shapes are different and we'll see how shortly, but for the rectangle, the across measure and the up-down measure, we times them together. Thing is, with this one though, we need to be giving our answer in metres squared, and that means that our two measures have to be in metres. The 4 metres already is, the 350 centimetres however is not, so we need to convert that to metres so that we can work with the right units all the way through the question rather than trying to faff about converting at the end. It's simpler and more correct, to be honest, to convert the units to what we need them to be at the beginning of the question. So 350 centimetres, well 300 centimetres will be 3 metres, 400 centimetres would be 4 metres, so 350, halfway between 3.5 metres. That means for our area, we are going to be taking the 4 and the 3.5, we are going to be timesing them together, and that will give us 14. 14 what? Well, that's metres times metres is metres squared. And again, for the rectangle, we have simply taken the across measure and the up-down measure and times them together. Now the next shape we need to be able to find the area of is the parallelogram, and it turns out it is easier than you might expect. Here is a parallelogram. Now on this parallelogram we could mark on various different things. We could, for example, mark on the height of the parallelogram, from top to bottom. We could also mark on the width, for example, the distance along that top straight edge. Or, of course, the distance along the bottom straight edge, which should be the same. They're offset, they're not directly above each other, but they should be the same. This width at the top and this width at the bottom should be the same. And in fact will be. And we could also mark on the length of that sloped edge at the side if we wanted. Now, some of these measures are going to be helpful to us for working out the area of this parallelogram. Some of them are not going to be so useful. And to work out which ones we need to use and how we're going to work out the area, we could do a nice little trick. And what I'm going to do is this. I'm going to cut this triangle off the side of the parallelogram. Why? Because now what I'm going to do is I'm going to move this triangle and join it on here instead. What shape have we now got? We are now looking not at a parallelogram anymore, we are looking at a rectangle. And we know how to work out the area of a rectangle. The area of a rectangle is the height the up-down measure, multiplied by the width, the across measure. So which ones do we need? Well, we need to be using this height and this width. The width has not changed. The width of the parallelogram is still exactly the same. The height of the parallelogram has not changed. The slope of the parallelogram hasn't changed, but actually it's just a line in the middle of the rectangle. It has nothing to do with the area. So that's how we're going to work out the area of a parallelogram. We are going to first of all redraw it as a rectangle, transfer the measures across, choose the ones we need. That's the width and the height. Ignore any that we don't. Ignore any slope lengths because we don't need them. And we can work out the area in much the same way that we did for the rectangle. For example, work out the area of this parallelogram. We have a 10 centimetre width across the bottom, we have a 6 centimetre sloped edge, and we have a height of 5 centimetres. We're shown it's the height with this kind of arrowed line. We could write that inside the shape like it's been done here, or we could write it outside the shape like that. Either is acceptable, and you will see both used in the exam. So, to work out the area of the parallelogram, we need to choose which dimensions we need to use. So what I'm going to do is I'm going to redraw it first of all as a rectangle. And I'm going to put in the sloped edge there. So we've chopped the triangle off one side, moved it round to the other. I'm going to transfer the measures across. Well, the vertical measure is the 5 centimetre height. So it's 5 centimetres in height. The across measure is the same, 10 centimetres, and the 6 is there on the slope, 6 centimetres. To work out the area of the parallelogram, well, it's the same as working out the area of this rectangle because we've redrawn the parallelogram into the rectangle. We just need to choose the measures that we need. So the area of this rectangle now, we take the across measure, we take the up-down measure, and we times them together. It's the 10 times the 5 is 50. 50 what? We're working in centimetres, so it will be centimetres squared, because it's still an area even though it's a different shape. The 6 centimetre sloped edge has nothing to do with the area, so we just ignore it. I'm going to start here with a rectangle. I'm going to do something to this rectangle that should be quite familiar, because we've done this before, but I'm going to go in a slightly different direction with it. I'm going to look along this top edge first of all, and I'm going to choose a point at random on that top edge, and I'm going to choose this point here. I'm then going to draw a line from that point to each of the bottom corners in turn. One to the bottom left, and one line from there to the bottom right. I'm going to do it nice and straight with a ruler. And you can see that we have generated 3 triangles. Now again, we've done this thing before. So, next step, I'm going to cut along those 2 lines and cut out the 3 triangles. So far, so the same. But at this point, I'm going to do something different. I'm going to focus on the largest triangle. I'm going to pick up the other 2. Now what I should be able to do is I should be able to put those 2 smaller triangles on top of the larger one. Now it might take a little bit of rearranging these, getting them to kind of sit in the right position, but I should be able to, even if I need to turn them over, I should be able to fit the 2 smaller ones exactly over the top of the larger one. And in fact they are exactly the same size. I would encourage you to try this out for yourself so that you can see that they are exactly the same size. So what I've done is I've taken a rectangle and I've cut it up into 3 triangles, 2 of which join together to make a triangle that is the same size as the other one. But then so what? Why does this matter? Well, let's just think about that large triangle. I have cut this rectangle up. What is true about the area of this triangle compared to the area of the original rectangle? Well, what I have effectively done is I have cut this rectangle up into a large triangle and then some smaller triangles that are the same size. These 2 triangles must have the same area. They've both come from the original rectangle. Therefore, the area of this triangle here must be half the area of the original rectangle. Half the area of the rectangle is contained in this triangle here. The other half is contained in these two here. But this triangle has half the area of the original rectangle. And that should be enough information to tell us how we can work out the area of a triangle. Work out the area of this triangle that is 8 meters across the bottom and 6 meters in height. That's from the base to the tip. Well, what we're going to do to work out the area of a triangle is we're going to say, okay, let's fall back on that one thing we know. We've just seen that the area of a triangle that we obtained was half the area of the rectangle we started with. So what we're going to do with this triangle is we're going to put it back into being a rectangle. I'm going to add in some dotted lines to turn it into a rectangle. I'm going to draw in the two triangles that we joined together effectively. That is now a rectangle. And I know how to work out the area of a rectangle. The area of the rectangle would be the 8 meters across the bottom times the 6 meter height would be 48 meters squared. Problem is, we weren't interested in the area of the rectangle, we wanted the area of the triangle. But what was the connection between the triangle and the rectangle? Well, the triangle had half the area. Therefore, the area of the triangle must be half the area of the rectangle, i.e. the 48 meters squared divided by 2 is 24 meters squared. And the triangle has an area of 24 meters squared. So with any triangle, step 1, turn it into a rectangle. Add in the dotted lines. I would strongly encourage you to draw in the dotted lines because then you're seeing what you're doing and why you're doing it. Find the area of that rectangle, choosing the measures that you need, and then halve it to find the area of the triangle that you actually wanted. Notice that we are only dividing by 2 here because we need to do that to get the area of the triangle. Don't start dividing by 2 if it's other things. This only works for a triangle, which is why we didn't do it for the rectangle or the parallelogram. We are dividing by 2 here because the area of the triangle is half the area of the rectangle that it must have come from, like we've just seen with the paper. Work out the area again, another triangle this time. We have 3 measures here. We have a 7 centimeter distance across the bottom of that triangle, we have a 4 centimeter height from the base to the tip of the triangle at the top, and we have a 5 centimeter slope length on that right hand side. It's a triangle, we're going to turn it into a rectangle. So this is our step 1, we're going to draw in the dotted lines to turn this into a rectangle. And in doing that, hopefully we will see which measures it is we need to use. We need to find the area of the rectangle. The area of the rectangle is going to be the distance across, that's the 7, times the height, the vertical height from base to tip, that's 4. 7 times 4 is 28 centimeters squared in this case. I'm going to keep track of the units through the question. Why am I not using the 5? Because the 5 has nothing to do with the area of the rectangle. It is just a line inside the rectangle. It is there not to trick us, but to make sure that we really know which numbers it is we need to use. We weren't interested in the area of the rectangle, however we wanted the area of the triangle, and the area of the triangle must be half the area of that rectangle, so the area of the triangle that we actually want must be 28 centimeters squared divided by 2 is 14 centimeters squared. Final shape now. Work out the area of the trapezium. Now a trapezium, remember, is a shape that has one pair of parallel sides, in this case top and bottom, the 4 centimeter and the 11 centimeter sides, and 2 sides then that do something else. They slope, effectively, but they do not slope parallel to each other. These two clearly are different length slopes as well. We don't even have to have measures on to see that that is the case. So this shape is not symmetrical about that kind of midpoint vertical line. We've got 2 different slopes. Finding the area of a trapezium is the most involved of the areas that we need to be able to work out. There's the most going on. But it turns out that we can use what we've already done to help us here. What we can do is we can think about cutting this shape up. Now, if we're going to be cutting it up, we want to be cutting it up into something useful. We've already seen 3 different shapes that we can find the area of, and we know how to do those. So surely if we could cut it up into, say, a combination of those, that would be pretty useful. And you might be tempted to say, oh well, surely we could cut the shape here and here to cut it up into 2 triangles and a rectangle in the middle. That would make sense, because triangles are easy enough to find the area of. A rectangle is very easy to find the area of. So we could do that. Problem is, with this, we can't. We know that this bit here along the bottom, in between these 2 lines, is 4 centimetres. But that's still 7 centimetres of length along that bottom edge to play with, some of which is going to go here for the base of this triangle, and some of which is going to go here for the base of this triangle. And we don't know how much. Is it the same on both sides? Is it 3.5 and 3.5? Is it going to be, well, 4 and 3? We don't know. And we can't be guessing, because that's not going to get us the right answer. So it turns out that while we are going to cut the shape up, this is not the best way to do it. What I'm going to do is I'm going to go from the bottom corner to the opposite top corner, and I'm going to cut this shape into 2 triangles. That's a triangle here, number 1, and a triangle here, number 2. Because we can find the area of triangles, and I can always do this. Next thing I'm going to do, I'm going to make a sketch of the 2 triangles. I'm going to sketch triangle number 1, and I'm going to sketch triangle number 2. Because then I'm just looking at triangles. I'm going to transfer some of the information across. Triangle number 1, this length across here was 4 centimetres. How tall was it? Well, it was 8. Triangle number 2, 11 centimetres across the bottom. And how tall? 8. What I'm going to do now is I'm going to work out the area of triangle number 1, then I'm going to work out the area of triangle number 2. And I'm going to do those exactly as I would for any other triangle. So for a triangle, what I do is I turn it into a rectangle. I'm going to draw in the extra bits. I'm going to work out the area of the rectangle, and then I'm going to find the area of the triangle. So the area of the rectangle. For triangle 1, 8 by 4. 32. But then we want the area of the triangle. (32) divided by 2 is 16 centimetres squared. We can do the second triangle in the same way. Turn it into a rectangle. The area of the rectangle, 8 by 11 is 88 centimetres squared. And the area of the triangle, half of that. (88) divided by 2 is 44 centimetres squared. So I know now that there are 16 centimetres squared worth of area in triangle 1, 44 centimetres squared worth of area in triangle 2. Therefore, the area of the trapezium should be the 16 from triangle 1 and the 44 from triangle 2 added together. 44 plus 16, 60 centimetres squared. And that is our final answer, 60 centimetres squared. Final type of shape that we need to work out the area of. Well, it's not really a type of shape at all. It's more shapes made up of other shapes. Now, these shapes could be made up of any of the 4 shapes we've just seen. So it's rectangles, parallelograms, triangles, trapezia, joined together. Tackling these questions is effectively very much like the trapezium one we've just seen. We're going to be cutting the shape up into what it's made of. There's usually more than one way of doing these questions. Sometimes there will only be one way of cutting the shape. It's clearly obvious what we're going to be cutting it into. Sometimes actually there's multiple ways to cut it. We should get the same answer overall though, because the area is the area however we divide it up. I'm going to look at this shape here then. So we've got another L shape. What I'm going to do then is I'm going to try and cut this into shapes that we recognise. Now we recognise rectangles, for example, so I could, for example, cut the shape here and make two rectangles. One here, number 1, and one here, number 2. What I'm now going to do is I'm going to redraw those shapes separately. I do really think that it is useful to draw the shapes separately because then you can keep track of what units you're using where. So I'm going to draw shape number 1 here. And I'm going to draw shape number 2 over here. 1, number 2. And I'm going to label the sides then. So number 1 is 10 centimetres in height and 4 centimetres across because it's this rectangle here, 10 by 4. Nice and simple, just transfer the information. Shape number 2 is 3 centimetres in height because it's this bit here, and, ooh, how wide is it? Well, that's not given to us because the 10 centimetre is the whole thing along the bottom. So we need to do a little bit of think back to that perimeter example. It's the same kind of thing. We need to fill in a missing side. The whole thing is 10 from one side to the other, and 4 centimetres worth of that is contained here. So we need an extra 6 centimetres to get up to the 10. 6 centimetres. We've now, though, got enough information to work out the area. So the area of shape number 1 is going to be the 4 centimetres times the 10 centimetres is going to be 40 centimetres squared. That's it. We don't need to do anything else with that. We don't need to divide it by 2 or anything like that. We are working out the area of a rectangle, and we work it out like we would for any other rectangle. We're only dividing by 2, remember, for the triangle. We can work out the area of shape 2 over here. The area of shape 2 is going to be 3 by the 6, so that's 3 times the 6 is 18 centimetres squared. Our final step then, all we need to do, is we need to take the 40 centimetres squared from shape 1 and the 18 centimetres squared from shape 2, and we simply add them together because the shape is made from joining those two shapes, joining those two areas. So our overall area then will be 40 plus the 18 is 58 centimetres squared. The idea of cutting the shape up will always work, but sometimes it's not necessarily going to be the quickest or easiest way to do it. It very much is a personal preference thing here. You go with whichever one you see first, and some people prefer the cutting up into pieces, and some people will prefer this kind of way. And in a lot of questions it is interchangeable. We should get the same answer either way though. So if the first way is to cut the shape up into bits, this second way is more of a let's make it complete. What I'm going to do is I'm going to add in this bit here. I'm going to add that back in because now we are looking at one whole shape. And I'm going to find the area of that whole shape. The area of the whole shape, well, it's a square now. It's 10 centimetres across and 10 centimetres tall. It's going to be 10 by 10 is 100 centimetres squared. But that's not very helpful to us because we didn't want the whole shape, we just wanted this L shape. So what we could do is we could take off the area of this bit and get rid of it. So now, this section here, well, how wide will it be? Well, it's 4 and then the extra to get to 10, so 6. And how tall will it be? Well, we've got 3 and then the extra to get to 10, so 7. The area of this, the area of the extra, is going to be 6 times 7 is 42 centimetres squared. So therefore, the area will be the 100 complete shape, less the 42 that we don't want, is 58 centimetres squared, and we've got the same answer as with the previous method.